All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 124 is on the screen. That shouldn't take you long. I'll give you guys some time. Copy and go. All right, shall we? All right, show your neighbor what you got for that warm-up really quick so we can get this show on the road. I'm still going to go over it just for the sake of time. All right, here we go. Number one, A. 2 to the negative 5 becomes 1 over 2 to the positive 5, which is 1 over 2 times 2 times 2 times 2 times 2, which is 32. 1b, distribute the exponent top and bottom. That's 1 to the negative third over 2 to the negative third. Since we can't have negatives, the 2 goes on the numerator, the 1 on the denominator, so this is 2 to the third over 1 to the third, and that is 8 over 1, or just 8. This 2, before it came out of the square root, what number was it in here? Tell your neighbor, what number was it before you took the square root? That was a number what? Yeah, 4. There's already 2 in there, so that means this is square root of 8. Number 2, 2 to the x minus 4 is 2 to the x times 2 to the negative 4, which is 2 to the x over 2 to the positive 4. So that's 2 to the x over 2 to the positive 4, that is 16. Number 3, half power is square root. Square root of 9 is 3. Half power of 64 is square root of 64, which is 8. 27 to the 2/3, we need to rewrite first. That becomes 27 to the 1/3 times 2 on the exponent. Then we circle the 27 to the 1/3. Since it's not a half, it's not a square root, it's a cube root of 27. Bring down the exponent of 2. So question, what number times itself 3 times gives us 27? That number is 3. 3 times 3 is 9, times 3, 27. Bring down the exponent of 2. So that is 9. Graph f of x equals 2 to the x. Remember yesterday we used 2 points, 0, 1, and 1, 2. And then, according to this, tell your neighbor where I'm going to move this function according to this. Where am I moving that? When? Three to the left and 4 up. That is correct. 3 to the left, 4 up, so we end up with a function somewhere up here. Number 5. Sine, cosine, and tangent of angle A. Circle your angle A. So sine is opposite over hypotenuse. And once again, what did I ask you to do? Label right away the longest side so that you know which one is the hypotenuse. So, if we're looking at the triangle from over here, what side is opposite to where I'm at? What side is opposite? Very good. 8. And the hypotenuse is 17. Next, cosine. Oh, my bad, I forgot angle A. Cosine angle A is adjacent over hypotenuse. Adjacent meaning next to. What side is next to the angle A? The side that's next to it is what? 15. So we do 15 over the hypotenuse, which is 17. Last but not least, tangent angle A. Opposite over adjacent. Which one is opposite again? 8. Which one is next to? 15. And that's my tangent. Hands if you got that by yourself. All right, good. If you notice I didn't give you the description anymore, by now you should know how to write these by yourself. All right, copy the agenda, please. Warm-up 124 is done. We're moving on to logarithmic functions. This is still, like I said, this is all part of the package. We're touching into pre-calculus here. So hopefully you did all your home play and your practice. Okay. And home play for tonight, pages 755, 756, numbers 5 through 15 only. So far, pre-calculus, what have I given you? I gave you a couple video lessons on the unit circle, is that correct? I also gave you guys exponential functions, yes? And now we're moving on to logarithmic functions, all right? All right. Once again, once you copy the agenda, go to Canvas, turn in your home play from last night. It was 4 transformations. All right, copy the code so you can access the home plate tonight. Code FA47C. It's an attachment of 2 pages. FA47C. FA47C. And like I said, last night it was 4 transformations for base 10 of exponential functions. Tonight is pages 755, 756, numbers 5 through 15 only. All right, get a Cornell note ready, please. I can define, solve, and evaluate logarithmic functions. I can define, solve, and evaluate logarithmic functions. I can define, solve, and evaluate logarithmic functions. You're like, what is that, Mr. Q? Well, we're going to find out today. Let's go. Logarithmic functions. All right, in your Frayer model, write this down. Logarithmic, in parentheses, logs, functions. So from this point forward in your math career, when you hear about these type of functions, instead of saying logarithmic, they're just going to shorten it by saying logs. What's a log? Very good. Definition says the inverse of an exponential function. Do you guys know what an exponential function is? Yes, we've been doing that yesterday and the day before. Is that correct? Yes, Mr. Q. So the inverse of it looks like this. F inverse of x equals log b of x. Or, another way of writing it, x equals log b of a. Now, it is fairly obvious if you look at it that this is a logarithmic function because it has what in its equation or in its function? Tell your neighbor, what does it have that tells you that it's a logarithmic function? What do you see? Caesar, what do you see that it has inside? What do these two have that would tell you that it's a logarithmic function? B, but we also did exponentials with B yesterday, right? What else is so obvious that it has that others did not? Yeah, the word log. That's how we know it's a logarithmic function. Examples. F inverse of x equals log 5 of x. 3 equals log 4 of 64. Copy that, please. So once again, these are examples, and Caesar said that it's obvious that they are logarithmic functions because of what? Can you repeat what he said, Geo? How do we know these are logarithmic functions? Yeah, because of the word log in it. That is correct. All right. So, with that said, look at these non-examples. Tell your neighbor why these are not logarithmic functions. Why are those obviously not logarithmic functions? Pass on one, Gio. Mario. Woo! Let's go. Man, what do you eat? My goodness. Oh, there you go. That'll work. All right, hashtags. It has to be a function. The base is b. Yes, we need to have b as a base. And to solve for exponents. This is something that we use to solve for exponents, and I'll elaborate a little bit more on that. Be nice, Mariah. All right, here we go. So, we know what logarithmic functions look like, what they don't. Now, what is so special about logarithmic functions? Well, according to the definition, they are the inverse of exponential functions. So why do we use this particular? Because mathematicians found that we've been solving equations involving variables, but usually the variable is the base. However, when it comes to solving for the variable being in the exponent, they needed to figure out a way of doing that. So that's why they figured out that logarithmic functions, or known as logarithm, look up to the screen, is a statement. Here it goes. I'm going to mute the music really quick. Look up to the screen. Don't copy this. What is a logarithm, Mr. Q? It's a statement that says, it's a question. What exponent does a base need to be raised to in order to get a given number? Let me repeat that again. The question is, a logarithm is to what exponent does a base need to be raised to in order to get the given number? Now, how do we write that with symbols? Look up. We write it like this. By looking at this, tell your neighbor which of these is the exponent. Which of these is the exponent? Mario, pass someone. Enrique, which of these is the exponent? Very good. The x, because that's in red. Very good. X. All right, guys, tell your neighbor which of these is the base. Which is the base? Enrique. B is correct. That's why I bolded B for base. And tell your neighbor which of these is the given number. Which is the given number? Everyone. A. A is the given number. Log, all log means is that we're solving for an exponent. That's what log means. So, with that said, now that we have this, copy this table on your paper, please. On the left side, the column, title it logarithmic function. On the right side, you're going to write inverse of log, in parentheses, exponential. All right? So on the left side, let's start off with this one. X equals log base B of A. All right? So here we go. Look up, please. I'm going to transform this log function, look up. I'm going to transform this log function into an exponential function. Everybody ready? Look up to the screen, writing utensils down. Look up, look up, look up. Here it goes. I'm going to transform this log into an exponential function. Question. What is my base, everyone? Everyone. What is my base? B. So I write B. What is my exponent? X. And all that to give us what given number, everyone? A is correct. We just transformed a log into an exponential function. So far so good, yes? All right, so now I'm going to give you another log function, but with numbers now. All right, here it goes. Copy that one. X equals log 2 of 64. All right, so question. We need to change this log into an exponential. Tell your neighbor what the base is of this log. Everyone? 2, that is correct. What is our exponent? X. And what is the given number that we need to find? 64 is correct. So we just transformed a log into an exponential function. This is part of your home plate. That's going to be the first part. All right, let's do one more. Write this one. X equals log 5, 125. Write your exponential function. All right, show your neighbor. See what they wrote. All right, you should have written 5 to the x equals 125. Hands if you got that. All right, good. Let me send you the screenshot. You send me your notes. Example 1. It says, rewrite the log as an exponential function. X equals log 416. All right. All right, show your neighbor, see what you wrote. All right, Sean, tell me what you write. 4 to the x equals 16. Hands if you got that. That is correct. All right, let's move on. Copy this one, example 1Q. Don't copy the instructions anymore, it's the same thing. X equals log 381. Rewrite that as an exponential function, please. All right, show your neighbor. Pass someone, Sean. Camila, what'd you get? 3 to the x equals 81. Hands if you got that. All right, so far so good. Let's do another one. Copy this one. X equals log 2 to the 1/4. And for this one, send me your exponential function once you're done on the screen, please. Not bad. All right, from 1 to 5, I'll come to borrow you with this so far. 5, 5, 5. Okay. So that's good and dandy. We've been going from logs to exponential, yes? But how about we reverse that? And we go now from exponential to logs. Copy this one, please. Example number 2. Copy the instructions. Rewrite the exponential function as a log. Focus, people, focus. All right. Let's see. This is an exponential. Now we need to write it as a log. What do I write first? Tell your neighbor, what would we write first? Everyone? X is correct. Equals to log. What is our base? 2. Base 2 to get 32. Hands if you got that by yourself. All right, let's do another one. Copy this one. Example 2q. 4 to the x equals 64. Write that as a log, please. All right, show your neighbor what you got as a log. All right, tell me what to write, please. Let's go with Geo. Log 4 to get 64. Hands if you got that. That is correct. Let's do one more. 2 to the x equals 1/8. We write that as a log, and then send it to me on the screen, please. All right, not bad, not bad. All right, give me the log, please. Mariah, tell me what to write. Hold on. X equals log 2 1/8. Hands if you got that. All right, so from 1 to 5, what control are you? Changing logs into exponential and exponential to logs. 5, 5, 5, 5. Okay? So now we're ready for the good stuff. Y'all ready? Oh, yeah. Here we go. And get the door, please, on your way up. Copy this one onto your paper. Example number 3. Now we're going to solve. We're going to solve a logarithmic function. It says solve for x. X equals log 2 to the 1/8. All right? So let's do this one together. Step 1, write it on the side. Change to exponential function. So change that to exponential first. All right, show your neighbor your exponential function. All right, so what is base? Base 2, exponent of x, and all of that equal to 1/8. So far so good, yes? Step 2, same base, both sides. Both sides need to be the same base. So here we go. Look up to the screen. How can I write 8 in base 2? 2 to the what gives me 8? Talk about your neighbor. 2 to the what gives me 8? 2 to the what gives me 8? All right. Elijah, 2 to the what gives us 8? 2 to the third. That is correct. So we write 2 to the x equals 1/2 to the third. Now, they almost have the same base, but this side, look up, needs to look like that. So what does that mean, Mr. Q? That I cannot have a 1 on the numerator. The 2 has to be on top. So question, think about this one. What would happen if I bring this to the numerator? Think about it. What would happen if I bring that one to the numerator? Talk to your neighbor. What would happen if I bring it to the numerator? Oh man, I can feel all that power in your brain. What would happen if I bring that to the numerator? Caesar. The 1 would disappear, and what would happen to the 3? That is correct. The 1 disappears, and the 3 becomes a negative. So we end up with 2 to the x equals 2 to the negative 3. Write that down, please. Yeah, because on the warm-ups, we've been going from here to there, right? So you just switch it to the other side, and it becomes a positive. So, step 3, last step. Solve for x. So look up. Now that we have the same base, look up. We don't care about the 2's because they're the same. Now we're just going to focus on the exponent with the equal sign. What is that equation? X equals negative 3. And that's how you solve a logarithmic function. All right, to make sure we got it, we were given a logarithmic function and they asked us to solve for x. What is the first thing we did? We changed it into an exponential function. What is step 2? We need to have the same base on both sides. There it is. However, the 2 has to look like that one. So we said if we bring it to the top, it becomes 2, but the exponent turns into a negative. Therefore, at the end, solve for x, ignoring the bases because they're the same, and we just focus on the exponents. All right, let's do another one. Copy this one. Example 3Q. X equals log 3, 1 over 81. Very similar to the one we just did. I'm going to give you a head start. See if you can solve for x. Go. All right, here we go. Tell me what to write right after this. Caitlin, go. Three to the x equals 1 over 81. All right. Continue. Pass on one. Mario's not here. Enrique, go. 3 to the x equals we need the same base. How can we write 81 using base 3? 3 to the what? Yeah. 3 to the what? 4th power. That is correct. Oh, sorry. There it is. 3 to the 4th power. Now we just need to bring this one to the top. So this becomes what? 3 to the x equals 3 to the negative 4. And last but not least, focus on the exponents. X equals negative 4. And if you got that by yourself, all right, let's do another one. Copy this one. Example 3, super cube. X equals log 4 equals 64. Very similar, but now we don't have a fraction. Now we have just a number. It should be a lot easier. So I'll give you a head start. Go. All right, just to clarify, here we go. First, change it into exponential. So we got 4 to the x equals 64. We need the same base. 4 to the x equals 4 times itself. How many times give us 64? That is 3 times. 4 times 4 is 16. Times 4 is 64. Therefore, Get it? Therefore, x equals 3. From 1 to 5, I'll come to you this. 4 5s, 4 5s, okay. So that's part 2 of the home plate. First part was to rewrite it from exponential to log, and from log to exponential. Second part to solve. Let's go to the last part of the home plate. Copy this one. Example number 4. Evaluate the logarithmic function f of x equals 7 to the x for 3 different evaluations. 49, 1 over 343, and 7 square root of 7. All right, we good? All right, here we go. Y'all ready? First things first, I'm going to do the first part, which is substituting 49 for x. So that means we're going to rewrite this, but instead of x, what am I going to substitute in there? 49. So let's write f of 49 equals log 7 to get 49. Okay, y'all ready? So, first thing we did was substitute whatever value they give us. There it is. Second step, we're going to change the function notation to y. Log 7 to get 49. Now that we have a log, tell your neighbor how to write this as an exponential. What would you write this as an exponential? How do you write that as an exponential? All right, tell me what to write, Rachel. Seven to the y equals 49. That is correct. Next, what do we do next, people? Your brain needs to tell you what do we do next. Change this to what? Same base, yes? So 7 to the y equals 7 to the what? What gives us 49? 7 to the what? 7 to the 2. That is correct. And last, we solve y equals 2. Are we doing? Good? Next, let's do the next one. Same thing. F of 1 over 343 equals log 7 of 1 over 343. All right. What is our first step after that? Mario, what do I do? Yeah, change it to y. Very good. Change this to y equals log 7, 1 over 343. Next, change that into an exponential. Tell me what to write. Caesar. Seven to the y. 343. All right. Next, we need the same base. 7 to the y equals 1 over 7 to the what? 7 times itself, how many times gives us 343? How many times? Mario says 3. Very good. 7 times 7, 49 times 7 is 343. Then we need to bring that one to the numerator. So 7 to the y equals 7 to the negative 3. So y equals -3. All right, the last one, see if you can do the last one by yourself. 7 square root of 7. If not, tomorrow we'll review that one once we get into class, but I'll stop right there. Those of you that are following along on YouTube, make sure you put in some work. Students logs, students, good introduction. Have a good one. See you guys next time. Peace.